At the bottom of page 61, we have an example. Use what you just learned to solve this problem. Show your work on a separate sheet of paper. We're not going to use a separate sheet of paper. The table and graph show how much money a store earns selling each team t-shirt and each team cap. Compare the rates of change for these two functions. Now, one function is being given to us as a table, and the other function is being given to us as a graph. The best thing you can do if you want to compare two functions is to put them in similar format. You could make a table for the one that's a graph, or you could take the table and you could plot it on the graph so that you could make comparisons. The only thing they want us to compare is the rate of change. Rate of change is fairly easy to compare if you put them on a graph. So let's just take this table and let's plot it on our graph so we can see what it looks like. Now, our original equation, our original team caps is here. I'll highlight it in yellow for you. Okay, that's the original one that's on the graph. Now, I'm going to add this table to the graph to make a second graph. So, 1, 4 is here. 2, 8. 3, 12. Doesn't fit. That's inconvenient. 10, 11, 12. That's going to put it up here. Now, you can use just the information that I just found. I really need a ruler. Ruler, fingernail file, it's all the same. Alright, if I was to draw a line through these two graphs so I could compare them. Now, they want us to compare the rate of change. Which one of these two lines, the purple one or the yellow one, is increasing the fastest? Which one is making us the most money? The purple line is making us the most money. So, the purple line is t-shirt sales. The pencil line in yellow there, that is caps. Okay, so we've got t-shirts versus caps. T-shirts are selling for more money. Okay, t-shirts are selling for more. Now, if we wanted to be specific, we would calculate the rate of change. Remember, rate of change is change in y over change in x. Delta y over delta x. Y's and x's. What is the change from 4 to 8 to 12 to 16? What's happening at each interval? How do I go from 4 to 8? Plus 4. How do I go from 8 to 12? Plus 4. How do I go from 12 to 16? Plus 4. So my delta y is positive 4. For my x's, I could do the same thing. From 1 to 2 is plus 1. From 2 to 3 is plus 1. From 3 to 4 is plus 1. Now, since all of those were the same, so our rate of change, okay, there was 4 was in dollars and 1 was in shirts. So our rate of change was $4 per shirt. Okay, the rate of change for our table was $4 per shirt. Now, if we look at caps, we could still do our delta y over delta x. Okay, delta y is up and down. So if we pick a point, and it could be any point, I'm going to start here. What is my change from 4 to 6? It's plus 2. And then what is my change? This would be my horizontal change. What is my change from 2 to 3? That would be plus 1. So the rate of change for my caps would be $2 per cap. So if we're comparing the rate of change in verbal description, you can easily see that they're making more money off the shirts than they are the caps. Okay, they're making $4 per shirt, $2 per cap. All right, on page 62, they're giving us another problem. Read the problem below, then explore different ways to compare functions. Miss White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. Mr. Brown also buys a used car. His monthly payment is shown in the table. Find and compare the rate of change and initial value for each function. Now, I told you that the best thing you can do is to put them in a similar format. Now, I've got the hiccups. Miss White was given in a verbal description. Mr. Brown was given in a table. Okay? We have two different ways to look at these problems. Now, in the Model It, they are showing you how to create a table for Miss White. Now, at 0 months, remember I told you the initial value, that's where you start. Okay, that's the beginning value. What was the beginning value for Miss White's car? If you look up here, she is buying the car for $3,000. So at month 0, she owes $3,000. That's your initial value. Then you use your rate of change to complete the table. Now they've already made the table. Her payment is going to decrease each month, or not, the payment's not decreasing. The amount she owes is going to decrease by $300 each month. That's how much her payment is. Okay, she's paying $300 a month. So we take our initial value, and this time we are going to decrease by $300. Okay, this is a decreasing function. We are going to decrease by 300. So 3,000 minus 300 is 2,700, minus 300, minus 300, minus 300, minus 300, and you just can keep subtracting 300 until you get to 0. And that's going to tell us how long, how many months it takes to pay the car off. So it's going to take Miss White 10 months to reach $0 on that car. Now, if we wanted to compare the two tables, we could. Miss White's car was $3,000. Her initial was $300. Mr. Brown's initial value was $2,400. So we know that Miss White's car costed more money. Now, her payment was $300 a month. To find his payment, we're going to have to calculate it. From 24 to 21, that's minus $300. And it appears that the pattern is subtracting $300 each month. So they're paying the same payment. His car just costs less money. So it shouldn't surprise you that his car gets paid off in 8 months instead of 10. The rate of change was the same, but the initial values was different, and that caused it to take longer to pay Miss White's car off than Mr. Brown. You could have also plotted those on a graph. Notice this time, these are starting way above 0. Your y-intercept, or your initial value, was at 2,400 and 3,000. Notice they was going down by the same rate of change, and then they reach 0 at different points. Now, this is a decreasing rate of change. Notice how those graphs are decreasing as you read from left to right. Okay, the lines are running downhill. That's where they're talking here about the negative rate of change. Number 7. Look at the tables on the previous page. By how much does the amount Mr. Brown owes decrease each month? $300. Let's make that a dollar sign. Okay, we are decreasing, which is negative, by $300 each month. By how much does Miss White decrease each month? It was also $300. Okay, both of these were decreasing, both of them by $300. What does your answer to problem 7 tell you about the rates of change for these two functions? 300 and 300, what does that tell me? It tells me they are the same. These questions, you overthink them. Okay, don't overthink them. It's just straightforward. How does the graph show this? Okay, it's the rate of change, or let's do the tilt. The tilt of the lines are the same. Okay, the tilt of the lines are the same. And we will talk about tilt, slope, rate of change a lot. It's coming. Number 9, what is the initial value for each function? What do the initial values mean in the context of the problem? Okay, Mr. Brown, Mr. B, his initial value was $2,400. Mrs. White, Miss W, her initial value was $3,000. And what does it mean in the context of the problem? It's how much they paid for the car. Or it's how much they borrowed to buy the car. It was the cost of the car. Number 10, fill in the blanks to write an equation for each function, where x equals the number of months and y equals the amount owed. Okay, so they want us to write an equation. Miss White started at $3,000 and decreased by $300 per month. Mr. Brown borrowed $2,400 and paid or decreased that by $300 per month. Number 11 says, does it take the same time to finish paying for the car with both plans? We've already said no. Explain why or why not by describing the rate of change and initial values. Because Miss W's car cost more, it will take more time to pay for when paying the same amount. Or the same payment. Slide that up where you can see it. Use what you just learned to solve this problem. Show your work on a separate sheet of paper. I don't think we'll need to do that. Number 12 says, below are two companies' rates for textbook rentals. What is the initial value for each function, and what is the cost to rent a textbook for 4 months from each company? Company A is giving us an equation. The cost, C, the total cost, is equal to 15M, or 15 times the number of months, plus 15. Now, I told you guys that the initial value is the constant. Okay, in an equation, it's the standalone number. It only happens one time. It does not repeat. So the initial value for this one would be 15. Okay, the initial value is 15. The rate of change would be the repeating number, the thing that happens over and over and over again. So the rate of change would be 15. Company B charges $19 per month per textbook. Now, they're charging a flat rate, but it's happening every month, which means it's repeating, which means that this is a rate of change. Okay, $19 per month is a rate of change. Now, if they aren't charging a fee, then that means that the initial value is 0. Okay, they're charging $0 up front. They're just going to charge $19 per month. Now, if they want to know the cost to rent a book for 4 months, we would have 15 times 4 plus 15 for Company A. And 15 times 4 is going to be 60. That's $75 to rent from Company A. Company B is just $19 per month for 4 months. So when we multiply 19 times 4, we should get 76. Similar in cost. Okay, Company B, that one's going to cost us $1 more, so we would probably want to use Company A. Right, and that is it for this page. You guys have any questions on this? All right, I'll leave it up there.